So this is question 2. Now 2.1 says 7x, y, and -1 is an arithmetic sequence. Determine the values of x and y. Now this question says that this is arithmetic sequence. Now one very important thing about arithmetic sequence is it has a common difference, which we normally represent as d. But unfortunately, we do not know the value for d, right? D is normally gotten by subtracting your second term from your first term, or subtracting your third term from your second term, and so on and so forth. But looking at this here, we cannot find out our value for d using this method, right? But we could use the arithmetic sequence formula to help us figure this out. Now, our arithmetic sequence formula looks like this. Tn is equals to, now our a from the question represents our first term, which is 7 over here. Now we notice that we do have some information in the fourth term over here, which is -11. We can put this into our arithmetic sequence, so it helps us find what our d is, right? So we say this. Now d gives us -6. X is our second term. If we add the first term plus our d, we will get the value for x. In this case here would be 1. And the same thing is also true for y. We need to add our second term plus our d, and that will give us -5. Those will be the answers for x and also the answers for y. And that's how we solve it. So 2.2 says, given the quadratic number pattern, -3, 6, 27, and 60. The first question under this question, which is 2.2.1, determine the general term of the pattern in the form of Tn is equals to an squared plus bn plus c. When you're trying to find your quadratic number pattern, the first thing you should try to do is get the first difference and the second difference of your original quadratic pattern. So what I mean by that is, the second line I have here represents my first difference. And this line here is your second difference. So now we need to find the a, the b, and the c from our general term. And to do that, we need to focus on the first values you have for each pattern. I need to be focusing on -3, I need to focus on 9, and I also need to focus on 12. Now, each and every one of these has a specific formula that you use for them. For the bottom, the formula we equate to the second difference is 2a. The formula for this is 3a plus b, and the formula for this is a plus b plus c. Now we start from the bottom, get our value for a, substitute into the second, get our value for b, then substitute into the third to get our value for c. So let's do that real quick. So from here we see that our a is 6, our b is -9, and our c is 0. Then finally we can now say our Tn is 6n squared minus 9n. Now we don't put c because obviously c is 0, and that's exactly how we answer this question. Okay. Now in 2.2, they ask us to determine the value for the 50th term of our sequence. So basically they're asking us what T50 is. Now the good thing is that we actually found Tn to be 6n squared minus 9 in the previous question. All we just have to do right now is substitute. And your value for T50 would be 14,550, and that will be your final answer. That's it. So question 2.2.3 says, show that the sum of the first and first differences of this pattern can be given as Sn is equals to 6n squared plus 3n. Now, the pattern they're talking about was this pattern, right? This pattern, the original pattern for 2.2. Now, we will be focusing on the first difference. Yeah, so the first difference I'm looking at is 9, 21, and 33. That's what I'm going to use to answer this question. So I start with the sequence 9, 21, and 33. From the previous question, we have a common difference here of 12. Now, another thing this question also says is that we're working with the sum of n. So whenever we're trying to get the sum, we use the Sn. And now, since this sequence gives an arithmetic sequence, we're going to use the Sn, the arithmetic series formula, which is exactly what I'm writing out right now. Since we're trying to get our general term, it means that we shouldn't find the value of Sn and we shouldn't find the value of n. So those two are not important. However, we need to know what A is and what D is. Now, A represents the first term, and from this our sequence, the first term is 9. And D is the common difference, and we can see that the common difference there is 12. Now, all we'll do now is substitute 9 and 12 into the sum formula. So that's what we're going to get. So as you see here, your Sn formula would be 6n squared plus 3n. So all we just had to do was substitute our value for A and D. After substituting, we tried as much as possible to open the bracket, then simplify, and at the end of it, you should get what they needed in the beginning, and that's it. Question 2.2.4. It says, how many consecutive first differences were added to the first term of a quadratic number pattern that has a value of 21060? On this side over here, this is the pattern we've been using for this question. This was the general term for our quadratic pattern. Okay, so let's break down this question. The first thing that the question says here is how many consecutive first differences, right? So first differences were added. So I'm focusing on my first differences, things like 9, 21, and 33. This first differences needed to be added to the first term, right? So they said the first differences were added to the first term of our quadratic number pattern, right? And this is the first term of our quadratic number pattern, which is -3. We're going to add -3 plus our first difference. So instead of we using 21060, let's say the value was 60. So let's say the question reads, how many consecutive first differences were added to the first term of the quadratic number pattern that has a value of 60? So I'm literally replacing this one here with 60. Now from here, we see that 60 is our fourth term. And we're asking how many first differences will be added to this -3 here to give you 60. We notice we need to add 1, 2, and 3, right? We add 3 first differences that gives you 60. So if you kind of put in your calculator -3 plus 9 plus 21 plus 33, you will notice you're going to get a 60 over there. So what you notice from this question is for the fourth term, you need to add 3 first differences. And you could also guess it. For, let's say it was 27. For the third term, you need to add 2 first differences. If it was T2, for the second term, you need to add 1 first difference. Okay? So for us to figure this out, we need to look at it that Tn is equals to this, and we need to find what n is. Because if you can find the value for n, you just need to subtract 1 from it, and that will give you the number of first differences. So let's do that real quick. The Tn formula was 6n squared minus 9, and this is equals to 21060. the next step is to factorize. You can use factorization using different methods. Either you use the quadratic formula or you can open two brackets, right? So I'm just going to plug this in my calculator and get the values. Now the values I'm going to get is because n here is negative, this will be not applicable. So this is the one we take. So our number of difference would actually be 59 first differences. And that's it.